Let's go to LeetCode 1810 minimal pass cost in a hidden grid. For this question, it gave us a grid master, which is a robot, and it has three methods, which is Boolean can move, which can pass in a direction, which is captcha, and can pass in U, P, left or right. And it has another method called move. This move is when return an integer. That is, this robot move to current cell, what the cost it will be. And if the robot is not able to move to current cell, then the move will be ignored. And also the robot will, the function is return -1. And also it has a function called isTarget, returns true if the robot is target cell. So let's return the minimal total cost to get the robot from initial starting cell to the targeting cell. It says that we have the range n and m smaller equal to 100. So we can set up, for example, 0 to 200 and 200. And initially, we are stay at 100.100 and 100. So this is a problem of hidden grid. The grid is not, or this board is not given by us initially. So we needed to use this robots method to get the grid first. So our thinking is that we first, these questions still have two steps. One step is use this grid master string method to a DFS, trying to see if we initial set as 100 and 100, if to DFS using the grids can move or is target to check whether it is able to reach the target cell, right? So for this kind of DFS, what we do is that we are going to return Boolean. The Boolean means that it is able to reach target. And also what we are going to pass in is that we are going to pass in integer array board, two-dimensional array board, right? So this board is that for each cell, for example, I, J will be when this will be the value when this robot is entering this cell, what the cost it to be. And we also need the target cell, right? So because this board, we put the cost to enter this cell, right? So we cannot mark the target as a number, right? So what we do is that we also can pass in the integer target and do the DFS to get this kind of target. So after we do this DFS, we have a board with initial start point as 100 and 100. And also we find the target. And then if it is true, right, that means we have a BFS or at least we are able to, there is a path from the start point to the end point. Then what we do is that we have a second step is that do the darkest search from the initial point to target, trying to find the smallest cost. So let's write code for this. So we know we are going to have the take the coordinations, right? So that will be 1, 0, -1, 0. And also we need to have a D column. So we need to have direction array array dir. Let's call. So I see we move row to increase by one, right? So this is sum, and we column increase by one. That is right, and the row decrease by one, and then this was left one. So this we have this kind of direction as arrays. So what we do is that we're going to have this kind of board. So we'll say this board have m and n small equal to 100. So let's have this one as 200 and 200, right? So what we want to do is that we want to do DFS find entering after DFS, the border ij will be if we enter in this cell ij, what is the cost for each cell, right? So we can initially set for this kind of board set it is -2 -2, right? So what we do is that we need this kind of target equals new int 2. Then we are going to for this DFS will return true or false. That means it can reach target, right? So return if DFS board master 100 100, then that we need to have weighted hash set, right? And also we need to have target. So if this one return true, then we're going to have a die-castra. So for this one, we'll consider what um, we want to pass in, and otherwise, we'll return -1. Right? When we talk about this, we'll try to pass parameters, and first function will be the boolean to do the DFS using this kind of robust, and we need to fill the values of the board. So after filling the board, it will be the cost entering each cell's value. Right? So we need passing the master and into row into column and hash set integer visited and also int target. Right? So this we're going to implement the DFS function. So I say if master is target, so we find a target. That means this row target 0 equals 0, right? And target 1 equals column and return true. And we'll have p equals row multiplied by 200 plus column. So if visited contains this key, right? Then we need to return false. Then otherwise, we put this one as visited, add this key, right? And then let's have boolean. Can we find the target? Set this one as false, right? For int k equals 0, k is smaller than 4, k plus plus. Then we're going to have int new row equals row plus d row k, and int new column equals column plus d column k, right? So let's say if new row is greater or equal to 200, or new row is smaller than 0, or new column is greater equal to 200, or new column is smaller than 0. We need to continue, right? And then we'll say if master can move, and this will be DIRK, right? If for this direction it is able to move, then we'll have board new row new column will be master dot move DIRK, right? So this is definition. So we are able to get this cell, and then we get the values when we enter the cell, right? So found should all equal to DFS for the master new row new column related target, right? And we should backtrack. So for the backtrack is or how can we backtrack? Is master. Um, so this is master move, right? So we should move to a direction, um, opposite direction. So we'll say D is going to up, right is going to left, or left is going to right, up is going to down. So what we do is that we are going to dir a plus 2 mod 4, right? If cannot move, that is else, right? So what we do is that we just set, for example, set this board. Um, we can set this one or to be 0 or -1, right? Whatever. Border new row, new column. Let's set this one 0. Okay. So in the end, that's the return fund. So this will be the DFS function. So after DFS, our board will be filled with the cost. Um, and let's set this one as -1. It means this is not able to achieve. Then we will need to think about the Dijkstra, right? So private this Dijkstra should return a cost. Sure, right. So this for this Dijkstra, what we need is that we need this kind of board. We already filled the values, and we need to have a start row, right? Uh, we can put the 100 and the 100 as well, right? Or start column, and then we need to achieve target, right? So what we do is that this one should have board 100, 100. And the target, right? So this target will also achieved from the first function of DFS. So what we will write is now we need to implement the Dijkstra, right? So we are going Dijkstra, we're going to have a priority queue, and we call main heap, right? Equals new priority queue. So for this priority queue, for those kind of array, we're going to have A, B compare with the third one of its cost. So that is when we enter in this kind of path, what's the cost it is, right? Integer that compare A to B2. Okay. So we are going to have a mean heap. Let's have a set weighted set integer weighted equals new hash set, right? So for this kind of question, right, we have priority queue. That means the first time we get to this is cell, the next time um, the cost will always be lower than the next time the cost. The robot visit is cell, right? So we can use a visit. That means the first time it reaches cell will be the smallest cost. So we're going to have mean heap of offer new int starter row starter column, and this initially the cost is there, right? And also visited add data row multiplied 200 plus stuff, right? So what we do is that while this kind of mean heap is not empty, then we're going to pull it out. So we're going to have current equals mean if data pull, and we're going to have a row equals current 0, and the column equals current 1, right? And the cost equals current 2, right? And what we do is that if row equals target 0 and column equals target 1, right? Means we reach the target. And because our mean heap is sorted by the cost, so that means the first time we reach this kind of cell, the target will be the minimum cost. It has return cost. Then what we do is for int k equals 0, k is smaller than 4, right? K plus plus. Then we're going to have int new row equals 0 plus the row k, and int new column equals column plus the column here, right? And also we need a new key, int new key equals new row multiplied 200 plus new column. So what do we say is that if new row is smaller equal to 0, or new row is greater than 2, is smaller than 0, or greater equal to 200, or new column is smaller than 0, or new column is greater equal to 200. Or this kind of board we mark as -1 or minus that is uh, blocked, or -2, right? So that is the initial value. So we'll say all this kind of board new row new column um, is smaller than 0, right? Um, and also weighted or weighted contains is kind of new here, right? In all of these cases, so we need to continue. Then otherwise, we just have visited the add new key, and also have a mean heap offer is new cluster, right? We should pass in the new row, new column, and should be the cost plus we enter this board, the new row. new column, right? So if we jumping out of the while loop, we didn't reach the target, we just return -1. So this will be the code. So doing like this, right? So if we have endpoint, uh, because we use the first time we do DFS, right? DFS will be ON if we visited endpoints, but for Dijkstra, we have a priority queue. So that will be n log n time complexity, but space is linear, that it will be ON, right? So we can also write Python code for this. Um, we need to import the heap, right? Import heap queue. Then what we need is in this solution, we can define the row, the column, and dir equals 1, 0, -1, 0, and 0, 1, 0, -1. And for this char will be d r u and left, right. So um, so what we need is that let's have this board equals -2 multiplied by 200 for in range 200, right? So this is a board initial the board, and also we should have a target equals 0, 0, right? So we'll say if self.dfs um, so if self DFS board master 100 set um, target, right? Then return self dot like Castra board 100 and target, right? Else that's a return -1, right? So we also need to write DFS in Dijkstra. So DFS will be DF or DFS. So self and board master row column related and a target, right? So this is for return true or false. If master is target, then we're going to have target if. Then we're going to have target 0, target 1 equals row column, right? And return true. And we'll have key, right? So key equals the row multiplied by 400 plus column. So if key inverted, then return false. Um, Then what we do is that we should have related head here, right? And we should have return a result. So we'll say found initially set this one as false. False. Then what we do is for k in range 4, right? So we have new row, new column equals row plus self dot d row k, and column plus self dot d column k. And so let's say if um if 0 is smaller equal to new row and smaller than 200, and 0 is smaller equal to new column and smaller than 200, right? So in this case, um, in this case, new row, new column. Of course, we also need the new key, right? Um, so key, if key related, um, we already added this one. So we don't need to have new key anymore because we are in the DFS main function here, right? So if this new column is in range, then what we are going to have a board new new row, new column equals DFS equals master dot move self dot dir is k direction, right? And then after we move, then we do DFS, and then we should master move back, right? This is backtrack, so that is self dot dir k k plus 2 mod 4, right? So um so in this case, we're going to have found should all equal to self dot dfs board master new row, new column visited and target, right? So this is if this one can move, right? If this is in range, we should and also we should check if can move, then we will remove, right? So if master can remove, can move self dot dirk, right? You can move, then we call the volume one, right? And you cannot move, that is else. Else. That's we just set this board. New row, new column equals -1. Then after this one, right, we need to return found. So this will be the DFS. So then we also need to write the Dijkstra. DF Dijkstra. So we have a self board and start a row start column target, right? So for this one, what we do is that we're going to have min heap equals so we order by the cost, right? So we put as cost at the first one, then start the row, start column. Otherwise, we need to have some kind of lambda, right? So we have um, visited equals set, and we're going to have visited add start. Mm, we can also have start row multiply 200, or you can add the tuple. You can also change this one as an integer, right? So then what we write is while uh, min heap is not empty, min heap, then cost row column equals heap q dot heap top equal top min heap, right? So in this case, we'll say if row equals target 0 and the column equals target 1, right? Then we return cost. Then for k in range, right, for directions, we're going to have new row, new column equals row plus self dot d row k, and the column plus self dot d column k, right? So we can have new key equals new row multiplied by 400 plus new column, right? So let's say if 0 is smaller equal to new row and smaller than 200, and the 0 is smaller equal to new column and smaller than 200. And for the new row, new column is greater than 0, right? So because for -1 or -2, those we are not able to beat. And and uh, and key not invalidated, right? Um, yes, not invalidated. Then we're going to have validated add new key, right? This is new key, and also heap q, heap push. So that will be min heap. So what we're going to push will be the cost plus for the new row, new column, right? And also new row, new column. And jumping out of the while loop, just return -1. So this will be our function. So